Welcome back to the Explainer. So glad you're here, because today we're diving into something seriously epic. We tend to think of the ground we walk on as, well, permanent, right? Just solid rock that's always been there. But actually, scratch that. We need to look at the Earth as this massive, living, breathing, and constantly moving puzzle. And to do that, we're taking a grand tour of the Indian subcontinent. We're going to explore a story of dramatic tectonic collisions, ancient oceans, and towering mountain peaks. It's a complete spatial tour, top to bottom, of a remarkably diverse landmass.
Okay, let's pull up our itinerary for today. We've got 6 stops. We'll kick things off with a subcontinent on the move, head up to the mighty Young Mountains, then drop down to the vast northern plains. After that, we'll check out the ancient peninsular plateau, take a quick detour through the arid Indian desert, and finally wrap up out at the coasts and coral islands. All right, stop number 1, a subcontinent on the move, geological history.
Now, I've got to ask, did you know that millions of years ago, the Indian plate wasn't even in the northern hemisphere? It's true. It was sitting way down south of the equator. The ground we're standing on has this wild, dramatic history driven by these massive forces deep inside the Earth. Back then, India was actually way bigger. And get this, it was literally attached to Australia. Crazy, right? To really wrap our heads around this, we have to look at the sheer scale of time involved. 4,600 million years. That's 4.6 billion years, which is the estimated age of our Earth. It's almost impossible to picture, but over that unimaginable stretch of time, tectonic plates shifting around and the slow, relentless grind of surface weathering totally transformed the landscape into what we see today. Let's track this journey. For a really long time, since the ancient Cambrian period, the peninsular part of India was just this rigid, stable block of rock. But eventually, the massive Indo-Australian plates snapped apart. The Australian section drifted off to the southeast, while the Indian plate started this incredible migration straight north. Cut to about 64 million years ago, and India absolutely slams into the Eurasian plate. That crash reached a pivotal point, creating a huge depression and violently thrusting up the Himalayas. And the biggest takeaway here? That journey is not over. That northward movement is still happening today, actively shaping the region's environment. Which brings us to Section 2, the mighty Young Mountains, the Himalayas. There is this absolutely fascinating structural contrast that defines the whole subcontinent. Up north, you have the Himalayas. Now, geologically speaking, these guys are young. They're weak, they're flexible, and they're born from tectonic chaos. They're still shifting around and being carved up by these intense, fast-flowing rivers. But then look down south at the peninsular block. Complete opposite. We're talking deeply ancient, rock-solid, stable granite and gneiss. It's literally a tale of 2 totally different geological worlds just existing side by side. Zooming in on those northern mountains, the Himalayas aren't just a few peaks. They're these massive parallel ranges stretching for an incredible 2,500 kilometers. But they do so much more than just act as a physical barrier. They are a literal wall, a massive climatic, drainage, and cultural divide separating the Indian subcontinent from Central and East Asia. They dictate the weather patterns, block the freezing winds from the north, and hold the massive glaciers that feed the most vital rivers in the region. Okay, moving on to Section 3, the vast northern plains, specifically looking at alluvial deposits. I want you to picture a giant trench plunging down 1,000 to 2,000 meters. Remember that massive depression we talked about, the one caused by the tectonic crash 64 million years ago? Well, over millions of years, those fast-flowing mountain rivers we just mentioned, the Indus, the Ganga, the Brahmaputra, they were busy. They dragged down an unbelievable amount of sediment and completely filled that giant trench. We're talking up to 2,000 meters of alluvial deposits. That is well over a mile of rich, packed soil, creating one of the absolute most fertile plains on the planet. So how does this actually look on the ground? If you're traveling from north to south, it's this perfect progression. As the rivers crash out of the mountains, they first dump all their heavy rocks and boulders into this narrow 8 to 10 kilometer belts called the Babar. The ground is so porous here that rivers literally just vanish underground. A little further south, they pop back up in the Tarai, which is this incredibly lush 10 to 20 kilometer swampy zone packed with vegetation. Keep going and you hit the massive flat plains made of older soil, that's the Bangar, and finally, the incredibly fertile newer river plains known as the Khaddar. It's a textbook example of erosion and deposition playing out right before your eyes. All right, let's head further south. Section 4, the ancient peninsular plateau. As you move south, the land rises back up to 900 meters above the plains, into the peninsular plateau. And the vibe here is completely different. It's this huge, irregular triangle of land. Forget the smooth, flat plains of the north. This area is rugged. You've got totally denuded rocks, massive rift valleys like where the Narmada and Tapi rivers flow, and block mountains. Up in the northwest, you even have these crazy, jagged ravines, like the famous ravines of Chambal. It's an ancient, battle-scarred landscape that's been lifted up and pushed down in recurrent phases for ages. Guarding the western edge of this plateau are the Western Ghats. These are serious mountains, boasting towering peaks like Ain Mudi, hitting almost 2,700 meters, and Dota Beta right behind it. Now, because the entire plateau is tilted, it basically slopes downwards from west to east, these high peaks act as the starting line for most of the major peninsular rivers. They start high up in the Ghats and flow all the way across the entire landmass to empty out into the Bay of Bengal.
Let's take a quick detour northwest for Section 5, the arid Indian Desert, or the Marusali.
Welcome to the Great Indian Desert. On the surface, it's exactly what you'd expect. Rolling, shifting sand dunes, brutal heat, and tiny ephemeral rivers that dry up almost as soon as they appear because of high evaporation. But here is the part that will blow your mind. Geologists have found marine deposits and 180-million-year-old wood fossils at a park in Akil, meaning during the Mesozoic era, this bone-dry desert was actually underwater. It was the bottom of a sea. If that doesn't prove how drastically the Earth reinvents itself, I don't know what does. Finally, we hit the edges. Section 6, Coasts and Coral Islands. Let's look at the coastlines, because the east and west coasts are practically opposites. The western coastal plain is what we call a submerged coast. The land drops off pretty steeply into the ocean, making it quite narrow. But that steep drop is absolutely perfect for deep, natural harbors, places like Kanla and Cochin. Now, flip over to the eastern coastal plain. This is an emergent coast. It's much broader, stretching way out into the sea with a shallow shelf, and it's totally dominated by massive river deltas from the Mahanadi and Godavari rivers. Because of that shallow buildup, you get way fewer natural ports. It's a perfect example of how geographic cause leads directly to economic effect. To finish our grand tour, we're heading offshore to India's two major island groups. And again, the contrast is just wild. Over in the east, in the Bay of Bengal, you've got the Andaman and Nicobar groups making up over 500 islands. These are super dynamic. I mean, Barren Island literally has an active volcano on it. But look west to the Arabian Sea, to Lakshadweep and Minicoy. These 36 islands are a completely different story. They aren't volcanic at all. They are built entirely out of coral deposits. And we usually picture the Andaman and Nicobar Islands as just flat, sandy beach resorts, but they're actually the rugged, elevated peaks of a massive underwater mountain range pushing up through the ocean floor. Places like Saddle Peak tower over 700 meters above the water. So the dramatic topography of the subcontinent definitely doesn't stop at the beach. As we wrap up today's explainer, I want to bring it all full circle. We started by saying the Earth is a living, breathing thing, right? Well, that northward sprint of the Indian plate crashing into Eurasia we talked about, it is still happening, right now as we speak, at a rate of a few centimeters a year. The Himalayas are literally still growing taller. Rivers are still carving out the plains. So I leave you with this highly provocative question. What do you think the physical environment of this incredible subcontinent is going to look like in another million years? Geological evolution is an active, ongoing story, and we are just lucky enough to be reading one spectacular chapter of it. Thanks so much for exploring with me today.